In this video, I want to talk about graphing an exponential function and its asymptote, where f of x is of the form a times b to the x power. So exponential functions are a whole class of functions that we haven't really talked about yet. They're functions where instead of having an x being multiplied by something like a polynomial or something divided by x like a rational function, instead x is in the exponent. And that's what makes it an exponential function. So x is in the exponent, so something's raised to the x power. And so let's just first talk about how we graph them. So typically we just graph something by plotting points at first, and that's a good way to start here. So let's start with this pink one, and we just want to plot points. Here, let me keep it in pink to be clear. So let's make a chart with x and y, and let's do just sort of our regular -2, -1, 0, 1, and 2. Let's try those. So when I plug in -2 for x, it'll be 3 times 2 to the -2 power. So the negative power is the same, so 2 to the -2 power is the same as 1 over 2 squared. So this would be 1/4. So this would be 3 times 1/4, or 3/4. Okay, so for the -1 power, we've got 3 times 2 to the -1 power. Now the -1 power just puts it in the bottom of a fraction, so that would be 3 times 1/2, which is 3/2. All right, now 3 times 2 to the 0 power, anything to the 0 power, anything raised to the 0 power is always equal to 1. And that's because 1 is the multiplicative identity, or it's the thing that when you multiply it by anything, it equals itself. So the reason is, so a to a power means a times a times a however many times. So a to the power no times is just equal to 1, because that's like what happens when you multiply nothing. So a to the 0 power is 1, so, or anything to the 0 power is 1, so it's just 3 times 1, which is just 3. And then 3 times 2 to the first power is just 3 times 2, which is just 6. And then 3 times 2 squared is 3 times 4, which is 12. Okay, so remember that exponents always come before multiplication. So you have to do that exponent first. So this wouldn't be the same as saying like 6 squared, which is 36. It's not the same as that. Okay, so let's go ahead and graph these points. So -2 is 3/4. -1 is 3/2, which is 1.5. 0 is 3. 1 is 6. Which is right there. Oops. 1 is 6, which is right here. And then 2 is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should be right there. So the exponential function goes up really, really fast, and that should make sense because we're multiplying. You might actually notice in our chart here, when we go up by 1 on the x, right? Every time here we're going up by 1 on the x. Here we're multiplying by 2. Right here we're multiplying by 2 and multiplying by 2 to get there. So every time we go up by 1 on the x, we're actually doubling it. So it goes up really, really, really fast. And when you graph it, it's going to go up toward infinity really fast. Now, when you go down here, it kind of looks like it's leveling off. So let's ask ourselves, what happens when you get a very big negative power? So a very big negative power, let's say 2 to the negative 100th, that is equal to 1 over 2 to the 100th, which is a very big number, like very, very big. So 1 over a huge number is very, very, very close to 0. And then we multiply by 3, it's still really close to 0. So what happens here is it gets closer and closer and closer and closer and closer to 0 without ever touching it, and that is called an asymptote. So there's an asymptote for this function that is at 0 because it's getting closer and closer to 0 without ever reaching it. So 0 is my asymptote. So this y equals 0 is the asymptote. And then this is the function f of x equals 3 times 2 to the x power. Okay, so let's go ahead and try another graph. See if I can erase this without erasing the graph. Very good. Okay, so let's try this one. Can we ask ourselves for one thing, what do we think this is going to look like? So an exponential, the other exponential function kind of looked like this, right? It kind of went down to 0 and then curved up to infinity really quickly. But this one, it's negative. So for one thing, everything about this is going to be negative. So it's going to happen down here somewhere. But also, it's a fractional exponent, so I'm not sure exactly how that's going to change things, but we'll have to see. So first, let's go ahead and do our xy chart here. -2, -1, 0, 1, and 2. Okay, so here we have 3/4, negative, and then 3/4 to the -2 power. So remember that the negative is multiplication, so that's done last, and first we do the exponent. So an exponent that's negative flips the fraction first. So this was like 2 over 1, and it flips it to 1 over 2. So this is going to take our 3/4 and make it 4/3 squared. So that's going to be 16 over 9. So this is going to be -16 over 9. Okay, let me get rid of this work just because it's kind of in the way here. Oops. Okay, so let's take -3/4 to the -1 power is going to give us just -4/3. Anything to the 0 power is 1, so it's just -1. -3/4 to the first power is just -3/4, and then -3/4 squared is going to be 9 over 16, and that's going to be negative also. Okay, so let's go ahead and graph those. So we have, let's see, -2 is going to be -16 over 9. So -16 over 9 is a little bit less than 1.5, or a little bit less than 2, sorry, between 1.5 and 2. And then -4/3 is just a little bit over, it's 1 1/3. Whoops, those are supposed to be negative. Shoot. There we go. There and here. And then at 0, we're at -1. At 1, we're at -3/4. And at 2, we're at negative 9/16, which is a little bit smaller. So we still do seem to be approaching this asymptote here. And again, as we get closer and closer to infinity, this graph is going to get closer and closer to 0 because a very small fraction is equal to 0, or is getting closer and closer to 0. Smaller and smaller fractions get closer and closer to 0. This exponential function is going up pretty slowly, so it's probably going to look something like this. But, well, it's going down pretty slowly, I should say. But it's increasing its value in the negative direction very slowly, but it is still exponential and it will still go there. If you wanted to test a point over here, you could, just to see what it would be. But the graph is going to look something like this, and the asymptote is still going to be 0. Basically, the only way to get an exponential function that doesn't have an asymptote of 0 is if we add or subtract something right onto the end. Otherwise, the asymptote is always going to be 0 because exponential functions, when they get, if it's a fraction, if it gets very large, or if it's a regular integer or a whole number or greater than 1, it gets very, as this gets closer to negative infinity, it's going to get closer and closer to 0. So the asymptote is always going to be 0 unless we have like a plus 3 or something on the end. So that's how you graph an exponential function and its asymptote of this form, f of x equals a times b to the x power.